So, hi everyone. Today we're going to take an introductory session on the Zilliqa blockchain. So, first, I would like to gratefully invite uh, Dr. Amrit Kumar, President and co-founder of Zilliqa, to give a brief keynote on this session. So, please, sir.
Thank you very much, Mobin, for inviting me over. And thank you very much, Kerala Blockchain Academy, for organizing this session about Zilliqa. So, of course, we have, Mobin is going to give a very, I would say, quite a deep introduction to what Zilliqa is, its consensus protocol, how it has established that sharding as a scalability solution is actually interesting for blockchains who want to scale their platform. We're also going to discuss about the smart contract language and Scilla. So we have seen, for example, the DAO hacks that have happened in the past. We have seen parity incident happen with contracts, and every other day we see contracts in the DeFi space getting hacked. So it's important to be able to sort of find solutions to those problems and not just wait until the next hack happens. So Mobin is obviously has been kind enough to do a presentation on this, and I will tell you what exactly and how exactly we are trying to figure out and solve some of these problems around scalability via new consensus protocols, via sharding, as well as building safer design, smart contract languages that allows people and developers to have a little bit of peace of mind in what they're building. So if any user comes out, he knows that this contract has been designed and written in a safe language. So Zilliqa is a blockchain platform very similar to Ethereum and some of the other L1s that we have seen around. And the two key benefits that Zilliqa offers is one around scalability. So it offers scalability through sharding. And Zilliqa is the first one to have implemented sharding on a mainnet. And number two is its smart contract safety features, which comes through smart contract language that we call Scilla. So I think that would give you a very high-level overview of what Zilliqa is. There's a lot happening in the Zilliqa ecosystem as well, ranging from DeFi activities, DEXs, tokens, NFTs, and many other things that we're going to touch upon in today's session. So over to you, Mobin. Thank you very much for this session.
So, okay, let me take the session. So, okay, let's start with the slides. I hope everyone can see. So, I'm grateful for Dr. Amrit Kumar to give us a brief sublime keynote on this session. So, in this session, we're going to talk about the introductory parts of Zilliqa and why is the first sharded public blockchain and what all the features does Zilliqa have over other blockchains. Other traditional blockchains and legacy blockchains, and what all there to learn in Zilliqa. We'll learn about other features offered by Zilliqa, like Block Explorer, the integrated development environment, the wallet, and specially new designed smart contract language called Scilla. So, let's get on with a rundown of this course. So first, we will talk about why is Zilliqa relevant in this scenario? Why is it popular? Why we should choose Zilliqa over others? What are all the features that Zilliqa have, which presides over other blockchain platforms? So then we move on to the other in-depth discussion about what all there to learn about Zilliqa. We will look into the consensus mechanism used by Zilliqa and the smart contracts and the language used by smart contracts, which is like a plus point in Zilliqa, where Zilliqa has been implemented as safe by design smart contract language called Scilla, and we will learn about Scilla and other functionalities in Zilliqa, and then the tokens, which are NFTs, which are in a super trendy position at this moment. And then in the third session, we will talk about how we can interact with Zilliqa, like the wallet we used in Zilliqa, and how we can see these transactions, like the blocks mined in Zilliqa. So we have a block explorer, which can be used in Zilliqa. and then the integrated development environment, and some other things where we can interact with Zilliqa. So let's move on to the first part where we talk about the relevance of Zilliqa, the features, like what all there to like Zilliqa have over other blockchains, and why we should consider Zilliqa over others. So let's talk about the conception of Zilliqa at first. So Zilliqa was founded at the National University of Singapore by academics, entrepreneurs, and engineers. It was a brainchild of people from different sectors coming together to solve what is called a blockchain trilemma. Like Dr. Amrit said, like in order to achieve a great public blockchain, we just have to have these features, which are considered as the blockchain trilemma, which are scalability, security, and decentralization. So the trilemma is that we have to sacrifice on certain aspects of one to reach like a perfection in other two. So in order to achieve scalability, you just have to compromise on certain facts regarding security and decentralization. So that's also in the case of security and decentralization. You need to have some compromises. So scalability is the main issue that faced by the previous public blockchains, where they cannot cope up with the increased rate of transactions in each public blockchains. So, I mean, they achieved their parts in security and decentralization by compromising on the scalability. So, Zilliqa solved this dilemma by using a mechanism called sharding. So, we will learn more about sharding in later slides. So, Zilliqa offers a scalable, secure, and decentralized platform. So the sharding mechanism will allow the Zilliqa blockchain to have scalable. Scalable means like how our blockchain can cope up with the increased number of transactions. And this is an issue faced by all the public blockchains, where they could not cope up with the transactions because the transactions per second for even the most popular blockchains are much slow, like too slow for compared with other centralized means of payments. And Zilliqa offers a secure environment by the safe by design smart contract language called Scilla. And they also offer a decentralization method as well. And from this graph, you can see how much Zilliqa has improved over like the transaction speed compared to the other blockchains. So when we compare like in the Bitcoin blockchain, you could only have transactions from 3 to 7 per second, which is much too low for when we comparing with other payment methods like in decentralized banking accounts and all the net banking. So in Ethereum's case, it's like 13 to mostly 15 at that range, which is also too low for considering. So when we look into Zilliqa, it has like using the sharding mechanism, it has enabled to have a much higher transactions per second. And from this throughput, we can see the differences in Zilliqa, why the new age is going to prefer Zilliqa over other blockchain platforms. And this shows like the implementation of blockchain in Zilliqa, like considering the number of 3,600 shards, 3,600 nodes in a blockchain. Zilliqa is able to like transact around 3,000 transactions. So by the increased number of nodes in the blockchain, we can also increase the transactions, and Zilliqa has managed to keep up with the scalability of the public blockchain. And now we could look at the scalability, how it affects the Zilliqa blockchain. So due to the scalability, the fees on Zilliqa is extremely low, which even allow micro transactions to be processed. So in the traditional or legacy blockchains like Ethereum or Bitcoin, you don't have to make transactions with less amount of cryptocurrency or whichever amount that prevalent in the blockchain itself. So it's because the gas fees of these blockchains have been so high that we cannot, it does not like allow us to have transactions, because making it like paying it gas fees much higher than the transaction, it's not really an like a favorable condition to any transaction, because we're paying more fees as gas rather than a transaction. So Zilliqa managed to have this issue being solved using the sharding mechanism, where the gas fees is much low compared to the other blockchains. And thanks to Zilliqa's consensus protocol, we can achieve a transaction finality which is much lesser than other blockchains, because Bitcoin and Ethereum uses a Nakamoto consensus, which use a probabilistic finality which have to wait around some time to finally confirm our transactions. So Zilliqa's consensus protocol, which we learn later in more about that consensus protocol. So it allows us to have a rather than a probabilistic finality, it has an absolute finality, which enable us to have a finality which is much less compared to the other blockchains. So it provides an absolute finality from around 40 seconds to 2 minutes, where we can be sure of the validation of our transaction within a less time. And let's move on to the main innovation of Zilliqa. So we all, up until this point, we only called it sharding. We never explained it how it works. So sharding, the process of sharding is already prevalent in the databases from around the 90s. So sharding in databases, like you divide the database into small parts so that you can facilitate the communication between the databases in a much faster way. So the Zilliqa team has implemented this mechanism into the blockchain itself. So we're dividing the blockchain into multiple concurrent networks, and we do transactions on each of the concurrent networks. So unlike in other blockchains where each node has to validate on every transaction, in Zilliqa, for a shard, you only get a subset of transactions. So we can enable a parallel process, like creating shards, multiple shards. We can give each of these shards subset of transactions so that we can process much larger amount of transactions. And there is a designated group which combines this output from each shards and create the block itself. So each shard commit a micro block which only process a subset of transactions, and there's a dedicated group which we learn later slides what we call that group, and this group combines all these micro blocks and commit the final transaction block. But there's certain issues that we have to face when implementing this sharding mechanism in a blockchain, because so we look into these underlying challenges a blockchain have to face when implementing a mechanism like sharding. So Sybil resistance, Sybil attacks is a phenomenon which is faced by all the public blockchains, because once the architecture of the blockchain becomes public, everyone can access to the blockchain itself. And this process, like being a decentralized and a public network, which will allow malicious users or nodes to come into the network, to come in contact with the blockchain itself. And these malicious nodes could end up creating multiple identities, multiple pseudonymous identities, and take over the majority in the blockchain, which is not a favorable thing for a public blockchain, because whenever a malicious node take over the majority-based decision process in a blockchain, it could inversely affect the blockchain itself, because it would in turn become a centralized network, because a node is able to make decisions without involvement of other nodes, because this node is has made multiple nodes and take over the majority. So this phenomenon is called Sybil attack. So like as being a public blockchain, Zilliqa is also like faced with this issue. So we will learn how Zilliqa overcome this Sybil resistance. And moving into the second underlying challenge, it's the shard creation. So how do we create these shards? Like I told about, like we are dividing our network into multiple networks. So how on which basis do we make these shards? So does any centralized authority make these changes, or they divide these like networks on their like favorable means or something? Like how this process can affect the blockchain itself? And the third being the shard size. So how do we divide the network? Like can we use like hypothetically considering a blockchain of 1,000 nodes, so can we do like make shards, like each shard containing 100 nodes being 10 shards? Like is it possible? Like can we achieve the intended throughput of the blockchain through like in that way, where we divide like 1,000 member blockchain into 10 shards, which with each containing 100 nodes? Is it favorable? So the underlying challenge of shard size is that how do we determine this shard size? So moving on, like how we will look into how Zilliqa like overcomes all these underlying challenges in the Zilliqa blockchain. So our first like issue was that the Sybil resistance. So how do we resist against these Sybil attacks? So keeping Sybil in check, in Zilliqa blockchain, they use a consensus mechanism which is called proof of work, but it's not used like as a consensus mechanism, but rather than as like in order to establish network identities, we use proof of work. So proof of work is a consensus mechanism in the blockchains we talk about earlier, like in Bitcoin and Ethereum, but we're not using proof of work as a consensus mechanism in Zilliqa, but rather as like in order to keep Sybils in check, we use as to establish the network identity. So any node that gets into the Zilliqa blockchain has to perform this computational task or proof of work, and if they can like yield the result, they can get into the blockchain itself. So using proof of work as like a gateway ticket in the Zilliqa, where we can filter the malicious nodes entering the system. So that's why proof of work is used as an entry ticket in Zilliqa blockchain stuff. And our next issue was the shard creation. So Zilliqa is an automatic shard creation. So Zilliqa elects a group of nodes, which we call as the Directory Service Committee or DS Committee, are a group of nodes, and each of these nodes are selected using the proof of work mechanism. So this committee like supervise on creating the shards, and once the committee is elected, it initiates the sharding process, and this committee designs or determines how we divide the networks into multiple concurrent networks. So the DS committee determines the process of sharding in Zilliqa. But moving on to the next, being the right sides of the blockchain. So like earlier I was talking about like a hypothetical situations where in 1,000 nodes, if we divide the 10 if we divide the 1,000 nodes into 10 shards, with each shard containing 100 nodes, is it possible? So by using the sampling method, the Zilliqa team has found out that if we hypothetically making a situation where like a 1/4 of nodes in 1,000 node scenario becomes malicious, the chances or the probability of the system being taken over is like 0.04, which is a less number, but we're using a blockchain and we cannot like fix on this small number. So we need a super majority number, which is much higher in order to facilitate and validate these transactions. So using the sampling method, the Zilliqa team has uncovered that minimum shard size of 600. When we using a shard size of 600 nodes, the probability of the malicious nodes taking over the system down to 1 in a million, which is much lesser compared to the scenario where we divide 1,000 nodes into 10 shards. So that's how we're choosing the right size for sharding in Zilliqa blockchain. And so that's all from the first session, where we talk about the introductory part, where we talk about the sharding and how the sharding enable the Zilliqa blockchain to have a much faster throughput compared to the other blockchains. And moving on, we talk in depth about the consensus mechanism. So at this point, we only mentioned it as like a consensus mechanism. We never talked about how we do the consensus. We never called it. And now we move into the consensus mechanism. We mentioned proof of work, but it's not used as a consensus mechanism in Zilliqa. So it is used for establishing the DS committee nodes and network identities in Zilliqa. So now, moving on, we will learn about the consensus mechanism and the smart contracts, how smart contracts are built over top of the blockchain and the tokens in Zilliqa. And first, we have the limitations of a Nakamura consensus. So Nakamura consensus or proof of work is the consensus mechanism, like I said, used in Bitcoin and Ethereum. So proof of work is a computationally intensive mechanism. Like it would require much time and energy to calculate or yield the result. So it requires time and can slow down the consensus protocol in the blockchain itself. But it provides a decentralized and secure way while like compromising on the scalability of the blockchain. And it mainly depends on the computational capacity of the network, and it can diminish this fact when the network is much less and proof of work cannot leverage on the small shard size, because like using a proof of work mechanism in a much less number would be unfavorable, because we use this small number of nodes have much intensive task compared to other blockchain like Bitcoin and Ethereum. We have much larger number of nodes, so using proof of work in that is favorable. So but in using proof of work as a consensus mechanism inside a shard is not really a favorable thing. So what do we do instead of using proof of work? So we need to move on into another consensus mechanism. So let's move on to the consensus mechanism which we use in the Zilliqa blockchain. So Zilliqa uses PBFT, which is the practical Byzantine fault tolerance mechanism. So I'm not getting into more about like the exact process or like the mechanism into PBFT. I'm only talking about the benefits. We will have more thorough and detailed explanations in later sessions in the future. So Zilliqa uses PBFT consensus, and by using PBFT, we have like certain advantages. So the first thing is the transaction finality, which we mentioned in the first earlier slides. PBFT provides us an absolute finality compared to the probabilistic finality nature of the Nakamura consensus. So in Bitcoin and Ethereum, in order to confirm our transactions, we just have to wait around, like it depends on the blockchain itself. So in Bitcoin is around 1 hour. So we take this much time because it uses a probabilistic finality, and in order to be sure of our transactions, we just have to wait around so that the blockchain itself create much number of blocks on top of our transactions. Then we can be sure that our transaction is finalized without being in the double spend process. So PBFT enables us with the transaction finality with an absolute finality, and whenever our transactions gets finalized and move on to the next block, it gets finalized. We don't have to wait around for like a 1 hour or something in order to be sure of the confirmation of our transaction. And the high energy efficiency. Proof of work uses much energy and time because it's a computationally intensive mechanism, and PBFT is not like that, and we use PBFT in each shards, which in turn gives us a high energy efficiency and much larger throughput compared to other blockchains. And each shard gets awarded. And like in a proof of work mechanism, a winning node, like proof of work mechanism is done in a set of nodes, and the node which completes the first, which finishes the computationally intensive task, get to build the block, and only that node can get the reward. But in Zilliqa, where we use PBFT in each shard, and each of these shard and each members get rewarded as well. So this will give us a lower variance than when it's compared to other blockchains. And we move on to the smart contract language of Zilliqa, which is Scilla, in short for Smart Contract Intermediate Level Language. It's a statewide design language, and it improves over other smart contract languages in other public blockchains. It is a statewide design, and it's also able to achieve expressibility and tractability. Like it is, we are able to express our the smart contract language is able to express functions in a much simpler way, where we can understand the smart contract much better, and it solves the underlying issues with other prevalent smart contract languages. So Zilliqa while using Scilla in Zilliqa provides us as much security as well as the scalability and decentralized factor which are needed for a public blockchain. And the token, like the cryptocurrency used in Zilliqa blockchain is Shilling. It's an industry's token because it gives platform usage rights to the users, and it has a finite supply. And Shilling keeps inflation in check because each transaction get burned, and in order to maintain the finite supply of Shilling and keep inflation in check. So Shilling is the inbuilt token or the cryptocurrency we used in Zilliqa blockchain. And moving on to the super trending and interesting topic at this moment is the NFT, like non-fungible tokens. Like we're hearing this term in our day-to-day life much higher when compared to the previous years, because NFT is like a huge trending topic at the moment. And so many public blockchain platforms enables us to have NFTs. So NFTs is like we can create NFTs and sell them for any uniquely identifiable work, like being an artwork, a video, or any of the uniquely identifiable artwork. We can create NFTs. So The thing with blockchains like Ethereum is that the gas fees, or like the fees in the blockchain itself, is much higher to create NFTs. So most of the users or artists move on to the other public blockchains to find like NFT marketplaces with much less fees. So they like these users or artists move into Zilliqa blockchain, and in order to have a less fee and a favorable like marketplace for the NFTs. So we already have a much higher amount of like NFT marketplaces in Zilliqa, being Unicutes, where we can, like in CryptoKitties, where you can buy an egg and hatch the monster, like using it like an NFT, and you can sell them. And also in Demons, it's like a collectible card NFT where you can buy collectible cards, and each of these cards are represented using NFT. And Zilliqa is also able to manage into the sector of gaming as well, like being Heroes of the Helm is a massively multiplayer online role-playing game where we can sell the in-game assets through the blockchain itself. So Zilliqa is able to achieve much faster and favorable conditions for gaming sector itself. And Blocks is a software development kit where we can design games with the Unity or Unreal Engine and combine it to the Zilliqa blockchain, where we can sell these in-game assets through the blockchain itself. So NFTs in Zilliqa has much favorable and a promising future in that sense. And Zilliqa is also managed to attain like certain decentralized applications. Major one of them being the unstoppable domains. It's the domain provider, which is based on the blockchain. So like Google Domains or Namecheap, where they provide domains for any sites we want, and only you can control the details regarding the domains itself, because it's blockchain, because it's using the Zilliqa blockchain. Only you can get to control these details. And Mintable is like an NFT marketplace where you can sell NFTs and create for any of the artworks or like the uniquely identifiable object. You can create NFTs and you can sell these NFTs through Mintable. And like I said, mentioned in the previous slide, Zilliqa is being used in many gaming DApps in order to sell the in-game assets through the blockchain itself. Another prominent DeFi also in Zilliqa, and also I'm going to mention about the DApps used in Zilliqa, like in SilSwap, where you can swap your ceiling to any other currency, or being any Ether or Bitcoin. And Scale network is a network which allows us the users of YouTube, like to a platform like YouTube, where the users can able to achieve like a decentralized manner. They can sell off their content to the audiences, and even the audiences can make profit out of the contents from these users itself. And that's all the Zilliqa ecosystem and roadmap. And so in the second session, we talk about the consensus mechanism, the smart contracts, and the tokens and NFTs. Moving on, we're going to talk about like wallet and explorer, and integrated environment in Zilliqa blockchain. So the first one being the ZilPay wallet, which is an equivalent of the MetaMask wallet in Ethereum, and where we can Zilliqa wallet allows us to connect to Zilliqa blockchain without much a complicated way. So you can use Zilliqa wallet to connect to the blockchain, Zilliqa blockchain mainnet, or you can use the testnet itself and connect to other decentralized applications. And it's a portal to the decentralized application, and we can upload our accounts into the Zilliqa wallets using the key store files or using the seed phrase itself. So Zilliqa wallet allows us to interact with the decentralized applications built on top of Zilliqa by while facilitating the transactions, which gives us an a much looking user interfaces for these transactions, and it allows us to connect to all these applications connected to the blockchain itself. And moving on to the next one, we have Devx, which is the blockchain explorer. So you can go into the devx.zilliqa.com site where you can see all these transactions, like all these details regarding the transactions, like the height, which is the block number at the moment. And you can see the micro blocks, how the sharding mechanisms work, how the all the nodes in the shards itself. You can see, you can watch which all shards contain which all nodes, and you can see the transaction rate, the number of peers, and how the networks it is divided. You can see the sharding structure, and it also enables us to have a detailed and organized display of accounts, transactions, and other details regarding the blockchain itself. And you can also view the testnet here also. And I'm just showing the main network. Also, you can see the test network in the Devx also. And the next one being the integrated development environment, where we build smart contracts. It's similar to Remix ID in Ethereum, where we build the smart contracts, and we can check the smart contract itself, and we can deploy it into the main network or the test network provided by the IDE itself. And Neo7 also provides us to learn about the Scilla language in a much tractable way, where we any of us can look into these smart contracts and learn how Scilla works. So they also provide us with some basic smart contracts, and you can also check that out in the Neo7 IDE. And it's also provide us to have a clear cut of transaction using Devx. So whenever we make a transaction or deploying a smart contract into the testnet, you can go into the Devx and see these transactions there itself. So you can see the contract creation and the transactions we made in smart contracts in the Devx also. And Neo7 also incorporates Devx to provide a clear cut of these transactions. And the next being the Learn Scilla, which is an interactive site where you can learn Scilla in an interactive way. It's like a game where for each chapter is like a quest, sort of, where you can complete all these quests and move on to other quests. So by completing these chapters, it gets the difficulty becomes higher, just like in games. So Learn Scilla also provides us with an interactive way where we can see how Scilla works and how the deployment in Zilliqa blockchain happens, and how Scilla is different from other smart contract languages. And here's a mere comparison between Zilliqa and the other famous public blockchain, Ethereum. So Zilliqa is launched on January 31st on 2019, and it uses the proof of work combined with PBFT consensus. unlike the proof of work and the proposed proof of stake consensus in Ethereum. Compared to the transactions rate, you can see like how Zilliqa's transaction rate or throughput is much higher compared to Ethereum. And Zilliqa also provides us with an instant transaction finality compared to Ethereum's probabilistic nature. And both platforms support smart contracts. And like since we use Solidity in Ethereum to write smart contracts, we used Scilla in Zilliqa. And like Etherscan, which is the block explorer in Ethereum, we use Devx. And for wallet related functions, we used Zilliqa. Now we're moving to the final session, what all future aspects we're going to implement in the Zilliqa blockchain. So let's move on to the future directions of Zilliqa. So Zilliqa plan is to have a stage sharding mechanism for the blockchain, because any node entering the Zilliqa blockchain have to perform in order to have the copy of the transactions from the beginning itself. So it's a case with every blockchain, but Zilliqa is trying to solve this issue using a stage sharding where provides each a new node with a favorable condition to enter into the network without having this jargon amount of transactions being, or the state of transactions being used for get entered to the blockchain stuff. And Zilliqa is planning to have a secure proof of stake consensus mechanism, which will also increase the throughput of the transactions in a much faster way, and the storage pruning. And each to have, like I said, to connect to the blockchain itself, we just have to have a higher storage. So Zilliqa has managed to solve this issue by using the state sharding. It will able to shorten the storage issues faced by other public blockchains itself, and a cross-chain support where we can interact with other blockchains through Zilliqa, which is a quite promising aspect, which we look into, because there's enabling a cross-chain platform will increase the throughput and the favorability towards the Zilliqa blockchain itself, and also a privacy preserving computation in blockchain itself, which will also increase the security features of the blockchain itself. So you can learn more about Zilliqa on all these sites, where you can read the docs regarding Scilla and Zilpay and the Devx, and also so Zilliqa JavaScript library provides us to connect, it provides us to build decentralized applications connected to blockchains, the Zilliqa blockchain itself, and also isolated server help. We can run a blockchain in our machine also, and you can check that out. And you can also check the white paper regarding the blockchain, regarding the conception and the architecture of Zilliqa in a much in-depth and detailed way. So that's all. I'm just going to conclude this small session of introduction regarding the Zilliqa blockchain. I hope everyone is able to achieve a simple introductory understanding of the Zilliqa blockchain and the consensus mechanism and the main innovation of the blockchain, which is the sharding mechanism and other functionalities provided by the Zilliqa, including the integrated development environment like Neo7 and the blockchain explorer, Devx, and the wallet Zilpay. And I already talked about the benefits of PBFT. You can also check on these docs regarding the mechanism, how PBFT has been able to achieve much throughput compared to proof of work or Nakamoto consensus in other blockchain. And we also already seen how like network sharding provides us with a much higher throughput compared to the other blockchain itself. So I hope everyone can able to understand a brief understanding about Zilliqa blockchain. So any questions? Okay, then I'll once again call out to Dr. Amrit sir to give like a brief conclusion note on this session. Please, sir.
Yeah, thank you very much, Mobin. To conclude, basically, if you are looking to build application and if you want safety for your contracts, and if you want scalability of your contracts, you want to make sure that when users come and use your platform, DApp, they don't have to worry about their funds getting locked, their funds getting stolen because of certain vulnerabilities in your contract. Give Zilliqa and Scilla a shot, and let us know what your feedback. We are continuously improving the Zilliqa platform, the dev tooling that we have. And obviously, the community, there's a large community of developers building interesting stuff on Zilliqa. So be a part of that community. We are very actively involved and communicating with developers on our Telegram, Twitter, and Reddit. So join our community and be a part of it. Thank you very much for your attention, and hope to see you soon again sometime.
Thank you, sir. Thank you for giving us like a supply conclusion note on this session. So I thank you everyone for like participating in this session. So thank you.
Thank you.